All right, welcome back. Let's use our critical numbers and our knowledge about the sign of the derivative to determine where this function here, x cubed minus 12x minus 5, a lovely cubic function, is increasing or decreasing. So the way to go about doing this is to first kind of find those places where the function could turn around. In other words, could like be going up and then start to go down again, or be going down and then start to go up again. Right? We know that that happens at these places called critical numbers, or places where the derivative is 0 or where the derivative is undefined. So the first kind of like even pre-step one thing you want to do is find the derivative. So go ahead and differentiate this. This is a nice polynomial, so it just needs those simple derivative rules. And you'll just get that f prime of x equals 3x squared minus 12. Now the next thing that we want to do is locate these critical numbers or critical points. Now remember that there are two kinds of like flavors of critical numbers or critical points. One of them is where the derivative is equal to 0. So that is literally just taking our derivative, setting it equal to 0, and solving it for x. Now be careful when you have an x in something set equal to 0 where the exponent is greater than 1. You want to try to factor if you can, because then you'll avoid some kind of potentially forgetting taking a plus and minus root if you end up having to take a square root. So anyway, I would take out a 3 here. And then there's a difference of 2 squares here, which I love to factor because they are just so symmetric and, I don't know, easy and cute. So we've got 3 times x plus 2 times x minus 2, all set equal to 0. Having a factored thing set equal to 0 is the best way to have this, because then all we need to do is set each of the factors equal to 0. 3 doesn't give us anything. There's no x's there. We will get an x equals negative 2 from the x plus 2 factor, and then we'll get an x equals positive 2 from the x minus 2 factor. So here are two critical numbers. Now we also need to check where the derivative is undefined. Now if you remember back from the introductory video, this happens when the derivative has a 0 in its denominator. Now our derivative does not have a denominator, so there are no places where the derivative is undefined. But it should be a good idea to get into the habit of writing this down so that we don't forget. Okay, so what we found here, what these two numbers are, okay, negative 2 and 2, these are places where the function, again, could switch its behavior or turn around, going up to down or down to up. But we don't know how this is going to happen. Like, we don't know if it goes like this, up, then down, then up again, or maybe it goes down, then up, then down again. And we don't want to have to guess, and we also don't want to use our calculator. We want to use calculus to determine what shape this has. So what this, way we're going to go about this is to make what's called a sine chart. A sine chart for the derivative. Because remember that the derivative's sign, meaning if it's positive or negative, that tells us whether the original function is increasing or decreasing. And that's what we want to find. So we're going to check out the sign of f prime. Maybe I'll just put all these things. So these things in boxes here, these are like critical pieces to the puzzle. Okay, now this is really just a fancy number line. So we're going to don't make it too tiny because it's going to get a little bit cramped. We're going to have to put a lot of stuff in here. We want to place our critical points or our critical numbers on the number line in order. So we've got negative 2 and we've got positive 2. And negative 2 lives to the right, or to the left of positive 2, so we want to put them in that order. Now this is going to divide up our number line into 3 separate intervals. Okay, we've got the interval from negative infinity to negative 2, all numbers less than negative 2. We've got all numbers between negative 2 and positive 2. Then we've got all numbers that are bigger than 2. And the point is that on each of these 3 intervals separately, whatever the sign of the derivative is at a single point in here, it's going to be the same sign for every single point in each of these intervals, because we found the places where the sign of the derivative could possibly change. We found all of them. So if we check the points that are in between and on either side of the critical points, if we check the sign of the derivative, we know for sure that it's not going to change somewhere in between negative 2 and 2, or after 2, or before negative 2, because these are the only places where that can happen. So what that means is that we can choose a test value that lives within each of these intervals. So let's choose a test value that's less than negative 2. So you could pick anything. You could pick negative 3. You could pick negative 4. You could pick negative 10.3. You could pick negative 1,000,000. Any number that's less than 2. The derivative is going to have the same sign for all of those x values. The number will be different, but the sign will be the same. And that's all we care about for increasing and decreasing. Okay, so over here, what we want to be doing down here is we want to check the sign of f prime on each interval. Okay, so let's test x equals negative 3, meaning let's plug in negative 3 into the derivative. All right, the derivative is 3 times x squared minus 12, so that'll be 3 times negative 3 squared minus 12. Negative 3 squared is 9. 9 times 3 is 27, and 27 minus 12 is 15. Now, I don't care that this number is 15. I only care that the sign of the 15 is positive. That's all that I care about. So I know that the function is going to be increasing until we get to negative 2, and then the derivative will be 0 there. Now I have to determine whether the function maybe continues to go up and increases more, or maybe it goes down and starts to decrease. That will be determined by checking the sign of the derivative on this interval. So we're going to pick a number that lives between negative 2 and positive 2. You could pick 0, you could pick 1, you could pick negative 1. I'm always looking for the place to plug 0 in because I think it's a really easy number to plug into stuff. So I'm going to plug in 0. So again, we're plugging 0 into the derivative. So we've got 3 times 0 squared minus 12. 3 times 0 squared is 0. 3 times 0 is 0. And so we've got negative 12 for our derivative sign between negative 2 and 2. So that'll be a negative derivative. Now again, if we plug in a 1 into the derivative, we will get a different number, but it will still be negative. If we plug in negative 1, right, another number between these two values here, we will get a different number for the derivative, but it will be negative. Okay, that's the whole point here. We're just looking for the sign of the derivative. So we know that the function goes up. It's got a derivative of 0 at negative 2. Then it does actually come back down. Then it'll have a derivative of 0 at positive 2. Now we have to determine, does it go up or does it continue to go down? And again, that will be found by checking out the sign of f prime on this interval. So let's pick another test value. How about 3? You could pick 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, whatever number you want that's bigger than 2. All right, we're going to square 3, that's 9 again, times 3 is 27, minus 12 is 15 again. So again, this is a positive number. That's all that we care about. Okay, so to make our conclusion, this is another vital piece to this, because if someone asked you where this function was increasing and decreasing and you gave them this chart, that's not going to be helpful. So that was just our work. Okay, the third important piece to this is making our conclusion. So we could say f of x, the original function, x cubed minus 12x minus 5 is increasing wherever the derivative is positive. So that'll be on negative infinity to negative 2, but then also 2 to infinity. Right? We had those two intervals where the derivative ended up being positive. Then we only have one interval where the derivative is negative. So it's decreasing on that interval from negative 2 to 2. And there we go. We have found the intervals where this function is increasing and where it is decreasing. Now, when you're working on these, we should definitely check our answers. And I don't mean like Googling the question, I mean graphing the original function. So let's graph it and then sketch a graph of what's happening next to our sine chart. So I'm just going to set up my axes here really quick. So here's x, here's y, and we're graphing the original function because that's what we're analyzing. Okay, so take out your calculator. If you don't want to go get your calculator, open Desmos or go to desmos.com or pull it up on your phone. It's a really cool site where you can easily graph stuff. So we've got y equals x to the third. I forgot what the function was. Minus 12x minus 5. All right, minus 12x minus 5. Okay. So I'm just kind of making it look a little easier on the eyes. So I think we did a good job, right? It looks like it's going up, then down, and then up again. We don't really care right now about the coordinates. We just want to consider the shape. Basically, does it go up or down? And where does it go up or down? Did we find the right places? It looks like at -2 and 2, those are the turnaround points. So yeah, so we did a good job. So let's go back and sketch the graph of this function. Okay, so the graph of this function looked like, sorry, I forgot exactly where the intercept was. I want to get it somewhat right. All right, so it looks like this, and it looks like this kind of, and then it looks like this. And the turnaround points, again, the critical numbers, we had at -2 and +2. And we had the function was increasing till we get to -2. Also from 2 on, so from 2 to infinity. And then between, from -2 to 2, we found the function was decreasing. And that matches with our picture. I think this is amazing that we can figure this out just by a derivative and setting something equal to 0 and then plugging in numbers and checking out the sign. It's kind of crazy and pretty cool. So in the next 3 videos, I've got 3 more examples that I'll separate out into videos separately in case you want to just go ahead and try some of these on WebAssign on your own. Sometimes it's just clicks with people. Other times they need a bit more practice. So tune into those if you'd like. Otherwise, I'll see you in section 3.2.